47. Yeah. All right, guys, this will be lecture number 8 in our series on Bible cosmology, the 5 worlds of Bible history, science, and prophecy. And right now we're looking at the flood. The flood is the bridge between world number 2 and world number 3. We're living in world number 3. World number 2, that was the world before the flood, but after the fall. Remember? And that was a horrible world, and God was just and justified in bringing in the flood on the world of the ungodly. And so now we're looking at the flood, and what I'm giving you is Dr. Walter Brown's hydroplate theory for what he thinks may have happened at the time of the flood in terms of energy, forces, and mechanisms that may have been at work. So I offer it to you. Now remember, the Bible says that the fountains of the great deep were broken up and the windows of heaven were opened, and we suggest that the source of the flood waters was under the earth, and that water erupted in extremely violent fashion, tore a gash in the earth, wraps all the way around the whole earth. And some of this material may have reached escape velocity into space, froze, and pelted the moon. And the lunar rocks are wet, which is kind of not predicted by the prevailing theory, the impact theory for the moon's origin. It might surprise you to know that we have craters on Mercury that have ice in them. Mercury is the nearest planet to the sun. The ice was deposited probably not that long ago. You know, we know there's huge temperature fluctuations on Mercury, but still, it's kind of hard to imagine ice in these permanently shadowed craters lasting for billions of years. And that's pretty interesting. On Mars, our other neighbor, we have Venus on one side, Mars on the other. Mars shows evidence of running water. Huge canyons have been scoured out. A lot of these canyons are right on the rims of craters. And we just suspect that frozen material from the Earth hit the red planet. The impact energy melted the ice, became liquid water, and left these gullies, deep gullies. Canyons on Mars are much larger than the Grand Canyon. These canyons were formed in a few weeks, according to Scientific American. This MSNBC article here says a ridge on the edge of the crater gave way, suddenly releasing the flood that carved the Ma'adim Vallis, said this scientist, Irwin. Unlike Arizona's Grand Canyon, which was carved over millions of years by the Colorado River, this one was made within a matter of months, certainly less than a year. So you can kind of see on the map there what happened. I think that is exactly what happened with the Grand Canyon. The Grand Canyon is an enormous spillway when 2 inland lakes breached their natural dams and scoured out the canyon. And we will talk about that in this course too. But just to show you that I think some of this material did make it into space, and some of it froze and came back down. It left craters on the Earth, big ones, like the big one in Arizona. And this material might be responsible for the frozen mammoths and bobcats and a whole lot of animals that we normally associate with warmer climates. They're now up there in polar latitudes, permanently frozen. And Dr. Brown suggests that it's this material that did it. This stuff went into space, froze, became super cold, and then came back to the Earth and trapped these guys standing bolt upright, just froze them solid. It created a heat sink. And that's why they're so perfectly preserved. A lot of these guys are absolutely beautifully preserved. The meat's still kind of fresh. But you can see way up in these Arctic latitudes, frozen mammoths, bobcats, rhinoceros, they're all frozen solid up there. Forests have been discovered up there, now frozen solid. So something has happened, and we want to talk about it in the course, what might have happened there. Lots and lots of, and I'll just mention it, the woolly mammoth, we call him a woolly mammoth. He's not really a woolly mammoth. He's got a long coat, and we always see pictures of him comfortably trudging around through the snow, but that animal's anatomy doesn't really look like he's designed for cold weather. You know, sheep live in warm climates too, and they got big coats, you know. He does not look like he's designed for it, and Dr. Brown goes into that in detail. But nevertheless, there they all are in these polar latitudes frozen. And we think that this might be a mechanism, And we'll explain what happened. We think the Earth actually rolled on its axis. So creatures that were living in warm climates got suddenly frozen, and when the Earth rolled on its axis, now they're stuck in the polar climates, and they're going to stay frozen. They're not going to thaw out. See? And we're going to talk about how that might have happened too. This is from Discover Magazine, article 1997. A scientist in his theory vindicated. He discovered that about every 3 seconds or so, a comet strikes the atmosphere, the Earth's atmosphere, and it deposits between 20 and 40 tons of water. Every 3 seconds, it's happening. This is happening continually, and it's into the ocean. Atmosphere, oceans, it makes its way into the oceans, ultimately. But this is a real problem now, because after 4.6 billion years of this kind of thing, we should have a lot more water on the Earth than we do. So this looks like something more recent that's been going on. And again, on Brown's theory, these small comets are not coming from the reaches of space. They're just water that was launched from the Earth. It's just falling back now. Right? The Earth has a gravitational field too. Now, this is a thing that really blows people's minds, but he suggests that the comets in our solar system, they were birthed right here. Okay? Now, it sounds crazy until you do the math, until you actually study the physics of it, and then you realize, wait a minute, this is not really crazy at all, actually. A comet is just a dirty snowball in space, kind of, A lot of water there. There is some petroleum hydrocarbons in the comets. Comets are huge, but they are very, very thin. They don't even cast a shadow. The tail of a comet doesn't even cast a shadow. That comet's tail is produced when the comet goes around the sun. Solar radiation is tearing the comet to pieces. And this tail of debris shoots out behind it, right? So even if a comet is moving away from the sun, its tail's out in front of the comet, actually, because solar energy is tearing the tail off that comet. Brown and others have pointed out that comets are always associated with catastrophe. In the mind of ancient man, comets are seen as omens of disaster. And Dr. Brown suggests this is because they were launched from the Earth in what was just about the greatest disaster, the greatest natural disaster, the flood of Noah's day. But the neat thing is about comets, they can't last that long. 10,000 years and they're done. That's on average. This is kind of what we estimate, seeing how fast the sun is tearing them to pieces and how fast Jupiter is sucking them into itself. Right? Jupiter is the biggest planet in the solar system. It's huge, and it's a giant vacuum cleaner. And it's pulling comets into itself and destroying them. So comets cannot last for more than, say, 10,000 years. And so to get around this, the fact that we still have them, scientists have proposed that there might be a shell of comets beyond the orbit of Pluto. They call that the Oort cloud. And maybe every so often, a star or something comes swooping in and it knocks a comet loose and it comes into the solar system now where we can observe it. Now, the problem is no one has ever seen this Oort cloud. It's more than 50,000 astronomical units away. I mean, an astronomical unit is the distance between us and the sun. And they want to say, that's 93 million miles. They want to say that 50,000 astronomical units away, we have a shell of comets that no one's ever seen. And every so often, one gets bumped loose. But there is not one shred of observational evidence to show that such a cloud exists. It's a knee-jerk reaction. It's a kind of just-so story to explain why we still have comets around here. The Christian explanation is, well, the comets aren't that old. Whatever their source, if you don't want to believe they came from the Earth, that's fine. Whatever their source, they're young, and they're not leftovers from the origin of the solar system 4.6 billion years ago. Now, it's interesting to notice, though, when a comet goes around the sun, it has this part in its orbit here called the perihelion. That's where it's nearest to the sun. Okay? Now, if a star came swooping into this Oort cloud and knocked a bunch of comets loose, you would expect that the perihelion for most comets should be kind of the same, and yet they're completely random. And that sort of argues against the idea that they just kind of got knocked loose by a... First of all, stars just don't go swooping in on things anyway, you know. Most comets, now this is a pretty good depiction here for you. A lot of the comets, their outer orbit, it seems clustered around Jupiter's orbit. See this red line here? This is the orbit of Jupiter. This is the inner solar system. This is where we are. A lot of comets seem clustered around Jupiter's orbit because Jupiter is so huge. But the idea is a comet coming in from 50,000 astronomical units away, moving towards the sun because of the enormous gravity that's there, it would keep picking up speed as it made its descent, and in fact it would be just slingshotted right out of the solar system. This is not a good way to catch comets. And yet we have 883 known comets in the solar system. What's the source for these things? They seem clustered around Jupiter's orbit, Jupiter's family, they call it, because of Jupiter's enormous gravity. But Jupiter is a comet killer. It sucks comets into itself because of its enormous gravity. Why are they still there? They're being destroyed. We're watching them get destroyed, you know. We would say, as the Christian explanation, they're just not that old. They haven't been destroyed yet because they're not billions of years old. See? Makes sense, right? Now, comets, very huge, but very thin. They have the density of about the density of a loaf of bread on average. So they're not real thick. As I say, Jupiter likes to destroy them. So comet Shoemaker-Levy was destroyed in 1994 when Jupiter sucked it into. These are marks left from the comet. Not a very great picture, but the question is, could the Earth... What's that? It's a terrible picture. It's from outer space. What do you want? 1994. What was going on in 94? Okay, comets are just gigantic, but very, very thin. And the question is, could the Earth really provide enough water to create 883 comets? Could we actually do it? Well, if we do some math, and I'm not real good at math, but I trust Dr. Brown, who's a PhD, teaches mathematics. 883 known comets. The average nucleus of the comet is 2.5 kilometers. That's a piece of rock in the middle of the head of the comet. He says 85% of the comet's mass is water, and we know how much mass is there. So he calculates if half of the world's oceans today, if half of that was under the Earth could have launched 50,000 comets. And that would have been only 1/1000th of what was actually there to draw from. So, and to just sort of distill that down, the Earth has way more than enough water. We could have launched 50,000 comets and not made a dent in our water reservoir that's here. Our water supply is more than enough. Okay. Then the question is, are we really the source of the comets? And I think it's a plausible idea. It kind of makes sense to me. This New Scientist article here, it says, massive ocean discovered towards the Earth's core. A reservoir of water 3 times the volume of all the oceans has been discovered deep beneath the Earth's surface. The finding could help explain where Earth's seas came from. 3 times the volume of all the oceans has been discovered inside the interior of the Earth. There's still lots of water in there. Back in 2005, NASA launched a probe out into space with a gun on it. Who would have thought? Something like a cannon shot an 800-pound copper bullet at this comet, Tempel 1. And what it did, it blasted a hole in the head of the comet. And all this material was ejected into space against the sun, and then they could do a spectrograph on it, and they could see what elements were there in all that material. They could figure out the composition of the comet. They found silica, ethane, carbonates, and clays as part of the comet's composition. Now we have a problem. The big problem surrounding these 2 compounds lies in the knowledge that carbonates and clays only ever form in liquid water, not in the icy outer reaches of the solar system where Comet Tempel 1 is believed to have originated. So the idea is, even our organic compounds have been discovered on these things too now. So we think we're just the source. It's not like life from outer space is coming to the Earth. It's like Earth launched a bunch of stuff and now it's falling back. Okay. The Scientific American article talks about asteroids in space being very damp. Icy discovery bolsters the view that asteroids delivered water to Earth. An asteroid circling the sun between Mars and Jupiter harbors water, ice, and organic compounds on its surface, the first time such components have been discovered on asteroids. We just theorized that all this material, asteroids and comets, we launched them, and it wasn't that long ago. Okay? That's the idea. This kind of thing is going on right now. One of Saturn's moons, Enceladus, was doing this. I don't know if it's still doing it, but we watched it for a while. This mission to Saturn sent these fascinating images of its closest moon, Enceladus. The two images, spectral analysis on the right, show a geyser of water shooting up from the surface, extending hundreds of kilometers into space. And this MSNBC.com article here, it tells us that scientists are puzzled as to what's going on there. And they said the best remaining models was that the geyser was driven by liquid water beneath the surface. Cassani's images showed that the geysers rose hundreds of miles above the surface. Based on the imagery, researchers concluded that most of the ice crystals fell back to the surface as snow. Some of the ice escaped Enceladus' gravity field to become part of a wide, thin ring of Saturn known as the E ring. So this kind of stuff goes on in our solar system, and we just suggest that it happened here on a much larger scale. And that's not too hard to believe if you're kind of watching it happen elsewhere, right? This article from the Winnipeg Sun I thought was very interesting. It came out in 2007. Now you have to get some background on this, guys. For a long, long time, Christians like myself would say, look, if you take a look at human population growth, as far back as you can go into recorded history, if you extrapolate backward, you can't possibly imagine that humankind has been here for hundreds of thousands of years. There just would not be standing room. You know, you go back a million years, there's not standing room for people. And wouldn't the upper crust of the earth just be loaded with dead bodies of people? You know, it was really outrageous. And the evolutionist community said, well, you guys don't know how to do your math. And the creation scientists looked at it again and again, and they said, no, we're doing the math right. You guys have to propose a human population growth rate unlike anything we've ever seen. It'd be like this flat line, you know, for hundreds of thousands of years, and then suddenly we get this growth. You know, it makes no sense at all. But in 2007, this article came out, and I'm just going to read it to you. It says a team of international researchers says that an explosion of a comet in the Earth's upper atmosphere 13,000 years ago caused the extinction of mammoths and the decline of Stone Age people. The researchers say that they have evidence of a comet or low-density object exploded, triggering a devastating swath of destruction that wiped out the most of the large animals, their habitat, and humans. The detonation either fried them or compressed them because of the shock wave, says Ted Bunch, a professor of geology at Northern Arizona University and former NASA researcher who specializes in impact craters. These people understand that comets played a role in the near extinction of humankind, and it was only 13,000 years ago. Hey, keep going, you guys. You know, you're getting closer. What happened to our math? I thought our math was bad. Now they admit humankind was on the edge of extinction by a large-scale natural catastrophe, and it involved low-density objects like comets. So you see, you kind of put this together, hey? It's very interesting. Well, Scripture says that the waters increased and lifted up the ark, and the ark rose high above the earth. I love that because God didn't need to tell us that. We could figure it out. If Noah made a barge, the waters came rushing in, the waters began to rise, we just know that the ark would be lifted up between heaven and earth. But the ark was mankind's only means of salvation against the global judgment, and Jesus spoke that way about himself. He said, I must be lifted up. If I am lifted up, I will draw all men to myself. And John tells us he said that signifying by what death he would die. So mankind's only salvation from a global judgment in the days of Noah, an ark of wood lifted above the earth, between heaven and earth. Judgment from above, judgment from beneath. And no doubt the ridicule of men. And yet, now, in the days of Jesus, we can say mankind's only salvation from the coming judgment was the Lord himself on a cross made of wood, lifted up between heaven and earth. You know, there's no extraneous words in the Bible. Though everything's there for a reason, you know, and you kind of see it, hey? So, again, we read that the waters continued to fall from the sky for 40 days and 40 nights, but the depth of the flood kept increasing for 150 days. You know, 150 days the water's still prevailing on the earth. And in fact, if you read the account, you'll discover that you have to do the conversion. A cubit is 18 inches, but it gives you the measurement there. At least 22 feet above the highest hills. At least 22 feet. And that's because there's an ark that's drifting around now on these waters, and God doesn't want the ark to bottom out. Okay? The details. It's the details. Okay, so all this tidal activity that's going on, you know, this is going to be a 371-day-long flood. All that water, I mean, there is a titanic amount of water sloshing around the Earth's surface. That's going to leave a mark. You should see some evidence of that, right? Well, I think we do in the layers of the Earth, the rock layers of the Earth. These layers they're all sedimentary layers. Everyone agrees, like in places like Grand Canyon, it was water that laid these things down. You know, it's just that their explanation for how this happened just makes no sense to me. You're going to tell me the whole Colorado region, thousands of square miles, just kind of sank down under the ocean. And then after, you know, several million years or so, just kind of got back up again. And then after a while went back down under. Every time it goes under, more layers form. And then, I mean, how does this happen without warping or twisting or cracking or erosion? Just horizontal layers, just flat layers, you know, like a birthday cake. How does it happen? Well, again, we talked about it. We have a moon up there in the sky. It tugs at the earth and it creates tides. And, you know, the tides, they reinforce themselves. The waves behave harmonically, don't they? And they reinforce themselves and they get bigger and stronger until they are stopped by something called a continent. You know, we're kind of getting in the way. But if the whole world was underwater, you can imagine enormous waves, you know, in the days of Noah, enormous waves. And when waves pass overhead, here's our wave peak. When that happens, directly underneath that wave, you have sediments on the bottom, and they're being compressed by all that weight. They're being compressed together. All the water in there is being squeezed out, you know, kind of compressed. And then when the wave peak passes, you now have a wave trough directly over top of that region of sediment, and the water's released, the pressure's released. And then the whole thing happens again. And what happens is the sediments are being shuffled and reshuffled and reshuffled. And you know what's happening? They're being sorted. They're being hydrologically sorted into layers. And you can do this at home. You get a jar full of dirt, all kinds of dirt, shake it up, put it down, it'll just layer out, won't it? You know, and you get pretty fancy, you can build a nice apparatus like Dr. Brown did and show you how liquefaction works. But this is this doctor, he wrote a letter to Dr. Brown. He says, I work in this mineralogy field, and I can tell you what you're saying to us is exactly correct. And I'll just read the letter to you. He says, during my working career, I was closely involved in a mineral process engineering and mineral dressing. A well-known technique in mineral ore dressing involves the use of the so-called mineral dressing jig. This is a device which imparts hydraulic water pulses to a bed of rock or mineral particles from below the bed. The particles are alternatively subjected to a lifting hydraulic force followed by a settling gravitational force. As a result, the particles are sorted, that is to say, stratified, according to density and size. A detailed description of the mineral dressing jig technique is available in any textbook on mineral dressing or on the internet. So what he's saying is, we do this artificially to sort out useful minerals and so on, but it's something that nature does anyhow. And nature would have done it in spades at the time of the flood. That's kind of the idea. That's one way that layers can form. The other way layers can form is through turbidity currents or underwater landslides. During a large-scale catastrophe, you can have a landslide underwater. We had one in Canada in the 1920s. Enormous amount of geological work was done in a very short period of time. Okay? So what happens with a turbidity current, all this material is cascading downhill and it begins to tumble. That's a better picture there. It begins to tumble as it falls downhill, and you have this sorting and this repeating pattern happening to the sediments. And then the whole thing lithifies, eh? This is from a earth science book here from the Smithsonian Institution. Talks about underwater landslides. Look at all that huge deposits here on the ocean floor. But this is the article here I was telling you about, this tsunami that took place on the Grand Banks. 27 dead in Newfoundland tidal wave. Wireless report brings news of great disaster. This is where it happened here, off Canada's coast. It says this here. Ultimately, the landslide was transformed into a turbidity current carrying mud and sand that flowed eastward up to 1,000 kilometers along the Atlantic floor and onto the Soham Abysmal Plain at speeds ranging from 60 to 100 kilometers an hour. The turbidity current had an estimated thickness of several hundred meters and must have flowed for at least 4 hours and probably about 11 hours. That's one little catastrophe on this planet. And an estimated thickness of 400 meters. 400 meters of layers, you know. And I got some pictures here. This is from Ireland, from southern Italy, just all over the world. You can see these are the result of turbidity currents depositing sediments and forming layers. So the point is, the layers that are formed during liquefaction and the layers that are formed during turbidity flows don't take millions of years. That's the point. You know, you read National Geographic and you'll see a guy, some scientist someplace, he's digging through rock layers. And he thinks the further down he digs, the further back in time he's going. You know, there's one article I saw, the guy's in the Alps climbing this mountain, there's all these layers under his feet. And the article says, you know, for every 10 feet that he climbs, he's moving ahead in time, you know, X number of thousands of years. And I'm saying, maybe not. These layers don't necessarily take all this kinds of time. Now, this is a very interesting article here in the Answers magazine. It shows in Grand Canyon, one of the layers there is a sandstone layer called the Tapete Sandstone. And they look at this layer and they examine it very closely. They're looking at the grain sizes that are there in that layer present, what kind of fossils are there, what kind of minerals are present, what's the chemistry of that rock, and what kind of features are there. They're really looking closely at the Tapete Sandstone. And they discovered that that sandstone layer covers the whole world. I mean, it goes just about everywhere. They see that it's in Arizona in the Grand Canyon, it's in Wisconsin, it's in North Africa, it picks up again in Israel. Something deposited that layer, and it was not a local catastrophe. The Austin Chalk extends from Texas right across the ocean too. This doesn't look like local stuff here. You know, this looks like something covered the world. You know, it's quite a. It kind of shakes you up, doesn't it? You go, wow, I think God really did judge the planet in the days of Noah. And this explains the fossils, the fossil record. A fossil is formed when a living thing is caught and buried in mineral-rich sediment in the presence of running water. You got to have those conditions, because the running water is going to wash out molecule by molecule the organic material, and it's going to replace that void with a mineral. And when the process is complete, all the organic material is gone, and all you got left is a rock. But it's a rock that looks just like the body of that animal. That's a fossil. That's how a fossil is formed. But fossilization is very rare. You got to have those special conditions, right? In the 1800s, armies of people were coming across the ocean, riding the rails in North America, and for fun, they were shooting bison. You stop the train, get off. Look at that, I'm a hero. I killed one of those beasts. And then they just drop dead right there on the plains, and then that's the end of that. You know what? As far as I know, not one of those things has fossilized. It's just not the right conditions. But a lot of them, armies of those things were dropped, It takes special conditions, Cat drops dead, and on your boulevard today, it's not going to become a fossil, And fish fossils, we find fish fossils by the bazillions. And again, fish don't fossilize. Fish are scavenged. They are dead. They don't float to the bottom and become fossils. They get eaten. How is it that we found so many fish fossils? It just doesn't happen, Unless they are caught, killed, buried quickly, and then preserved. Okay? And we know this happens quick. Look at this fish fossil here. See this guy? Look what's in his mouth. You see that? That is a fish eating another fish. He's not even done dinner. Yeah, he's either he's eating that little fish, or the little guy's a dentist, right? Lenny's heard that one before. Okay, here's a swordfish. He was caught in the act of spearing his enemy there. Delicate structures like dragonfly wings have been discovered. Fossil jellyfish, whole beaches full of now fossilized jellyfish. Something catastrophic happened. A jellyfish won't last long. There's not much to it. Fossil crinoids and sea lilies, very delicate structures, all jumbled together, fossilized together. In Florida, there's a place called the Love Bone Beds with over 1 million fossils in there, all jumbled together. And you've got fossils of things that fly and things that crawl, and they're all in there together. In Germany, they discovered what they say are 47 million-year-old turtles fossilized while they're copulating. I can just imagine all the jokes that are going on right now in people's minds. Okay. 9 pairs of them were found in the act. Now they're all fossils. These things are supposed to be 47 million years old. First of all, no evolution has happened. They look exactly the same today. That's kind of odd. And they got caught and buried quickly. They're still in that posture. That's just gonna get away from that now. In that posture. Okay, here's another one. This creature, kind of looks like a dolphin, right? You see this fossil skeleton? Looks like a dolphin, but it's actually a swimming reptile, now extinct as far as we know, called an ichthyosaur. The ichthyosaur here was caught and buried and became a fossil, and it's in the process of giving birth to its young. This has to happen quick. That happened very quickly. At the Creation Museum in Cincinnati, or near Cincinnati, huge blocks of shale, I think that's shale. Look at all the herring that were caught and killed. Fish, all jumbled together in some kind of aquatic catastrophe. I'll just share this one more thing with you. Does anyone know what these are? I'll give you a color picture. You know what that is, anybody? You ever recognize that? You ever see something like that? It's a diatom. A diatom is a tiny microscopic creature with a body that's made of kind of like glass. It's a very strange little creature. But diatomaceous earth is dredged up, and they use diatomaceous earth for all kinds of things, fertilizers and pesticides and all kinds of stuff. But diatoms die, and then they kind of fall to the bottom. And it would take a long time to create even an inch thick layer of dead diatoms. It would take a long time, But anyway, we harvest this stuff, and we do all kinds of stuff with it. In Lompoc, California, they have the largest diatomaceous earth quarry. Okay? Now, it's right near the San Andreas Fault. I want to show you what was discovered there in that diatomaceous earth. Zillions of fish fossils. This is a big block of diatomaceous earth. Zillions of fossils of fish trapped in that diatomaceous earth. Now, remember, it takes like maybe 1,000 years or more to get an inch of this stuff. Now, how did all these fish wind up in there, all jumbled together? It looks like something came through and killed everybody at the same time. Killed a bunch of diatoms, and they all went to the bottom. And other things that were killed instantly fell into that graveyard of diatoms, and buried it. But in Lompoc, they discovered a baleen whale buried in diatomaceous earth. And that whale is tipped kind of, not exactly like, he's not on his tail like that, but he is tipped. Something has happened and the earth has shifted. We'll talk about maybe what would happen there next time. But even if this guy was laying flat on the ground, you still got something like 8 feet of thickness, 8 feet thick layer of diatoms covering him. How did that happen? And evolutionists themselves agree some large-scale catastrophe happened there. But you can't just keep pointing to local catastrophes all over the earth, and then say, we deny that there could ever have been a large-scale aquatic catastrophe. And in this course, believe me, I'm giving you a lot on the flood, but there's probably 3 times as much as I could give. It's pretty interesting stuff. My opinion, I think they were scalded to death. I think hot water coming out of the earth probably burned them. I kind of think that. The diatom. I think the temperatures got to them. Possibly that's what happened. But I don't know for sure. But I know that all these critters were caught and buried quickly, otherwise we wouldn't find them today. So I think I'm going to leave it there. Are there any questions? Next time we'll continue on with the flood. I think we might finish the flood next time. And then we'll get on to the post-flood world, which is fascinating. It's the world we live in. And God's been doing a lot of stuff on this earth in this third world system. Yes, Martin.
I'm not a scientist, and I plugged at school big time. But where are the human beings in this diet? Why do they call it diatomaceous?
Oh, this is just a fanciful depiction of the thing. The early reports of what happened, what was discovered in Lompoc, said that the baleen whale was found standing on its tail in this diatomaceous earth. So scientists came and began excavating, and they found this thing standing on its tail, And
The human beings in the cell, that's what I'm trying to say. Is there any fossilized human beings?
Oh, okay. So you want to know, have we ever found human remains jumbled in with some of this stuff? I say yes. There was a book that came out in 1870 by the state geologist F.S. Holmes. He was the state geologist for South Carolina. And he reported in the phosphate beds there that he had discovered all kinds of animals in only 9 inches of vertical thickness. He discovered mammoth remains, he discovered hadrosaur remains, dinosaur remains, and he discovered human remains there too. And he wrote a book about it. And there's other instances too that I could probably remember. I'm kind of on the spot here. But that's the one that stands out to me. Right. Now the other, we're going to talk about it in the next lecture. We're going to get to something called ecological zonation. Ecological zonation it's a name to describe what happens when living things are caught, killed, and buried where they live. We're going to talk about altitudinal biomes, where different kinds of life, animals and plants, live at different altitudes. So if a large-scale catastrophe came sweeping through and buried everybody, you're going to find them basically where they lived. That's called ecological zonation. So we don't normally live with whales and sharks and stuff, so we're not normally fossilized with them, right? Although plenty of exceptions too to the rule, like in California and Florida. So, but as a rule, there is a quasi-ordering to the fossil record. There's at least some kind of order there, and a lot of it is due to ecological zonation. That's one reason. Animals were also sorted in with respect to intelligence and mobility. Clams and snails, they're not too smart. They don't see a catastrophe coming. They don't run very fast. Human beings, we head for the high ground. We're smart enough to do that. Our bodies have low fossilization potential anyways. So there's just not a whole lot left from the pre-flood world in terms of human presence. But that's to be expected, you know. That makes sense?
You find that you already revealed that some of these other things which are very fragile are still fossilized.
Right.
So the human remains over for you.
Yeah.
Similar like the fish, for example.
Right. Again, the humans are smart, kind of, and they would be heading for the high ground. And in our bodies, if they're not buried and covered, they float and bloat and get scavenged. You know.
So that's what would happen to the people.
I think so. You remember Titanic? Who doesn't remember Titanic? Okay. How many people died? Like 1,500 people died. And when Robert Ballard discovered that ship back in '86, not a single shred of human remains down there. There was nothing. We could see pairs of shoes where bodies landed. The boots are there, but the body's totally scavenged. We just don't fossil. We have low fossilization potential. Now that doesn't mean we haven't found human fossils. We have, but it's very rare. It's kind of rare, you know. So, and that's my answer to that one.
So when you say caught quickly and covered,
Yeah.
you have to be covered with like mud,
Mud.
right? Okay.
Yeah.
And die there in order to make fossil.
Right.
So even if a person is buried with mud and liquids out of it and whatever.
Yeah. He needs to be buried. He needs to be covered in mud. That's the bottom line. Yeah. If a guy goes to the top of a tree or something, and then the floodwaters pick him off, and he just drowns, he's just going to bloat, float, and that's it. Get scavenged, rot. He needs to get buried. So, and that's kind of the idea too. A lot of people, you know, like Dr. Brown suggests, you know, when the pre-flood people see this supernatural procession of animals heading into the ark, they know something's about to happen. And some of them may have been heading for high ground at that time. I mean, it just, we kind of do that, right? We try to preserve ourselves. So. Hey, Danny, you had a question?
Back to that thing about the moon and the water bubbles hitting it.
Yeah.
Do you think the moon was a lot closer to the Earth than what kind of science believes?
The moon was closer to the Earth for sure, because we're losing the moon now. It's receding like 4 centimeters a year or something like that. But you can go back 6,000 years, and it's not close enough to cause any problems. But you cannot go back 4.6 billion years, because at the rate of lunar recession that we observe right now, if you spin the clock backwards, you can't get any closer than 1.5 billion years. That's as far back as you can go. Otherwise, you hit a limit there where the gravitational forces between these two bodies are going to start destroying each other. Right? So, and this is a well-known problem, actually, in cosmology. They want to say the Earth-Moon system is 4.6 billion years old, but it can't be anything older than 1.5 billion. Now that's a problem. And so they have all kinds of ways to try to wiggle out of it. They say, well, maybe the form and distribution of the continents was different, and therefore lunar recession was less, and all this kind of stuff. But yeah, maybe they were different, and maybe it was even worse for you, right? So, yeah, but that's a good question. Yeah. Are there any other questions we can try to tackle here? No? Okay, guys, well then I'm going to have a word of prayer, and we'll be done for today. Father, we thank you for your goodness and kindness. Thank you for this day that we can come together and think about these important issues. And Lord, may we go home tonight and have a good rest. And may we, Lord, in the week to come, contemplate these things that we're learning and be critical in our minds, but Lord, may we do all things with love, and may we be bold, powerful, and effective witnesses for Jesus Christ and His gospel. And we ask it in His precious name now. Amen and amen. Okay. Praise the Lord. God bless you all.